The fog is parting, and we can start to see El Nino. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 24th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. If you'd like to make a small contribution, you can. Just hit the special thanks button down below, the heart with the $sign in it. And with that, I'd like to thank the folks that donated in last week's video. Kim in California, Jason Odom, Francis Tuckerman, Spat Out Glory Film, and Mont the Drifter. Thank you all so much. We really appreciate it. And with that, let's get to work. Looking at significant wave heights for the North Pacific, yes, we actually have a gale developing off of Oregon, producing 23-foot seas aimed off to the southeast and forecast to build. It appears that fall is finally started and not a moment too soon. But let's start by taking a look at current conditions. We'll look at the buoys. Point Reyes Buoy in Northern California, 029. We're looking at all the energy that's hitting the buoy from way up 33.3 second period, super long period energetic swell energy, which there is none, the whole way down to 5 second period, just pure wind chop. We see a little bump here at 13 seconds, probably coming from the southern hemi, pretty small. And then a little bit of wind swell mixed in here at 9 seconds. You put it all together, you see primary swell 1.5 feet at 14.1 seconds from 193, yep, from the southern hemi. That makes for 2-foot surf, and that's probably being a little bit on the generous side. And then there's the wind swell mixed in at 1.9 feet at 9.8 seconds from the west-northwest, 286 degrees. Again, about 2 feet, and it's just lapping in at knee-high, something like that at most breaks in Northern California. Looking down south, Southern California, the Point Loma South Buoy, number 191. All we see here, all that northwest wind swell, which isn't much of it. This is all shadowed. Southern hemi swell looks like all there is in the 13 second period range. And primary swell 1.7 at 13.3 seconds from 196 degrees. Again, that makes for 2-foot surf. And top spots actually were, maybe waist, maybe chest high in the peak, something like that. So rideable at some spots, but nothing great. And then we go over to the south shore of Oahu, again looking at the energy. There's a little bump there at 18 seconds coming through, another little bump at 12 seconds, some wind swell mixed in. We're using the Kauai buoy, the Lanai buoy, 239 here. It's a little bit more protected from the wind swell. Primary swell 1.9 feet at 12.3 seconds from 186 degrees. It's about 2.3 foot surf. And then that secondary swell, 1.1 feet at 17.8 seconds from 196 degrees. And that comes in at about 2 feet too, and surf is, thigh high or so. So nothing special going on anywhere. And so then we go look at the Hindcast. That is what's been happening in the past. And it was just yesterday, Saturday, 23rd of September, this little tiny gale tried to start building here in we'll call it the northwestern Gulf. And then it wound up into Sunday. And here we are right now with our 24.1 foot seas, the highest seas over this whole domain, being generated supposedly by 50.6 knot winds in the same location. So actually more in a gale if it has 50 knot winds. That would be a storm, but we'll see. We'll get into the details here in just a second. All right, so let's look at what's coming for the next week. We're going to start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, a dip in the jet, which we clearly see right off the Pacific Northwest here, being fed by 170 knot winds. That helps create a counterclockwise flow aloft and down at the ocean surface. And a counterclockwise flow is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds get traction on the ocean surface and start generating seas. Seas, as they radiate away from the fetch area, get groomed out, eventually turn into swell. swell when hits your beach turns into surf. So it all starts with a trough, and we have one, and it's in the Gulf, and we already know that it's productive. And the jet stream itself looking pretty good over the North Pacific. Finally, maybe now fall will start. All right, we'll put this into motion. Sunday into Monday, the trough continues good, starts pushing into Oregon and the Pacific Northwest. This would literally be an atmospheric river pushing into, we'll say, extreme North California and Oregon. Still supporting gale development Monday into Tuesday, and then the trough pretty much fade out, moves inland. Still, weather north of this trough for this whole area here. South, things high and dry. Jetstream still consolidated, looking pretty good as we get into Wednesday the 27th, but no real troughs until we get here into Thursday. Another trough, kind of small, kind of pinched, kind of tight, starts developing in the Dateline region, pushing east into Friday and to Saturday, and then pushing up north of the Aleutian Islands. That's supportive of gale development. Now, also notice, we're going to go back here just a little bit. Another trough also starts building here along the Pacific Northwest on Friday, falling south down into California and right down along the coast. If this was deeper into winter, we go, oh, that would look like a good cold system and maybe a snowmaker. We don't think that's going to happen, way too early in the year, but at least maybe a signal of what's to come. Now we're a week out. We're on Sunday, October 1st. It looks like another trough trying to organize over the dateline, digging a little bit deeper. The jet really consolidated, looking pretty good. We're looking for signs of El Nino. Maybe we can see some of it, or maybe it's just the fall and this is the way things go. But typically, as El Nino builds, it starts feeding the jet stream. The stronger the jet stream gets, the more you have storms. And then you really start counting the number of storm days and the strength of those storms and the aerial coverage of those storms to get a sense of how much is it El Nino influenced or how much is it just the change in seasons. Right now, too early to know, but at this stage of the game, we'll take anything. Next up, surface level pressure and surface level winds. No surprise, we have a gale here off of the Pacific Northwest with 45-knot winds aimed well at the U.S. West Coast. It's already getting traction, generating seas. As we get into Sunday night, 060, that's like 11 o'clock on Sunday night, West Coast time. We have, we get up to almost a little pixel or two there at 50-knot winds, but certainly 45-knot winds aimed at the whole U.S. West Coast. Now, this is a pretty steep angle for, anywhere south of Point Conception, but north of there, this looks like it could generate swell for sure. The gale finally starts fading out on Tuesday, the 26th, and pretty much all but gone. We're looking for anything new. High pressure starts building, and then here comes another little system forecast on Thursday, and late Thursday, what do we have? 40-knot winds out of the west aimed again at the U.S. West Coast, building to 45 knots late Thursday night into early Friday, lifting off to the northeast, and still continuing on to even Saturday with 35-knot winds. Now we notice, actually, let's go back here just a little bit. You can also, remember, there's a trough forecast here. You can see some winds created by that relative to California. We'll get into that more in a minute. And then another low forecast on Sunday, moving off, starting to build, and yet maybe something else off Japan. Nothing super strong, nothing super noteworthy, but again, there is a consistent pattern, it appears, trying to build if you believe the model's a week out, and we'll take it. Next up, the effect of those winds on the ocean surface. Well, quickly, as we get into later this evening, we see seas building right here, barely 30 feet, we'll call it 29 feet, and continuing at somewhere, there's a pixel of 30-foot seas right there, but as we get into Monday morning, a clearly more defined area of 32-foot seas off of Oregon, and that fades a little bit, 30 feet, midday Monday, down to 26 feet, and then fading from there. Swell likely expected into California from 305. I actually did the math and figured it all out. 305 moving to about 310 or 311 degrees. That's for San Francisco area, maybe a degree or two steeper down here. Southern California, pretty shadowed, 310 degrees, which is like pretty much like wind swell. So whichever spots get wind swell from a super steep north angle, maybe some of the swell will reach down into there. Anyways, we get into Wednesday, things settle down. Then here comes our next low on Thursday night into Friday with 30-foot seas aimed off to the east. This morning's run of the models had it up to 33 feet, I think, or even 34 feet. So the model's jumping around, not completely sure on how this is going to play out or if it will even play out at all. But still, seas holding in the 27-foot range into Saturday. That's certainly good for swell, at least down to Point Conception if it all materializes as forecast. And then we have our next little low trying to get organized, but not particularly great. We'll see how that goes, but at least something to monitor. Forecast for the southern hemi. As of right now, we didn't do a hindcast on it, but there's really nothing that's happened over the past week. No significant swell of any kind pushing off to the north, not even hardly background swell. Looking forward, we see there is a little gale down here forecast on Tuesday night into Wednesday. The cutoff for, let's see, San Diego's about 117 west, so anything west of here is good. We see a tiny little area fetch for about 12 hours with seas to 36 feet, all aimed due off to the east, and then out of the California swell window. Doubtful that any swell will result. And then looking beyond that, that's out of the picture. Another system forecast right here on the hairy edge of the window again. Let's go back and just look at that. I mean, that fetch is so tiny, it's pretty much meaningless. 26-foot seas on Thursday aimed off to the northeast. Maybe a little tiny bit of background swell into exposed breaks in Southern California week. So that'd be a week from Thursday. And then something here over in the Tasman Sea. That could be good for maybe background swell for the South Shore Hawaii. Again, this morning, this system was supposed to redevelop off the northeastern tip of New Zealand, but now this run of the model not showing anything. So for the most part, whatever swell is generated probably will be buried in swell coming from the north and of no particular interest at this moment in time. A quick look at the local wind forecast. Okay, here's your gale. Here is Cape Mendocino here, San Francisco there, Point Conception there, Southern California down there. Already south winds starting to build along the Cape Mendocino coast, theoretically at 15 knots or so. Front pushing in on Monday, also relative to Hawaii. Trade's pretty light. So we get into Monday, the front pushing into Cape Mendocino with 20, maybe 25 knot winds from the south. But given that it's early in the season, the front pretty much blows out as we get into Tuesday. A light wind regime for North and Central California. Trades for the Hawaiian Islands at 15 knots. The low continues circulating. Still, as we get into Tuesday afternoon, the clearing high pressure starts building in behind. See the building wind pattern relative to California, 15 knots, 20 knots for Central California, if not more. Trades 15 knots for the Hawaiian Islands. Wednesday, you have this the standard northwest wind regime. Still hasn't completely broken up. 15 to 20 knots for California early on Wednesday. Trades for the Hawaiian Islands. So we get into Thursday, then we know there's a trough setting up. I don't know that it's going to do anything in terms of precipitation, but it will set up a gradient. Lower pressure inland, higher pressure off the coast. That tightens the isobars between the competing pressure systems, generating wind, and we have 20, 25, almost 30 knot winds on Thursday morning along the California coast. Trades for the Hawaiian Islands. Friday, northwest winds still at 20 knots. Pushing to 30 knots Friday afternoon over Northern California. That will certainly generate wind swell. Trades for the Hawaiian Islands, 15 knots. Saturday, a blown out mess, 30 knot winds for all of North California and 20 to 25 knots down to Point Conception. Wind swell production for sure. So we get into Sunday, finally things start mellowing out. 10 knot northwest winds. Trades continue for the Hawaiian Islands. We'll just take this the whole way out. Things mellow from there. Precipitation forecast, California starting right here. This is California. Just looking for any rain. Of course, into Oregon, rain for sure looks very likely. Here we go as we get into Monday afternoon. Rain start pushing down to about, let's say, Point Arena and maybe to Point Reyes overnight Monday. Tuesday, I wouldn't even call this rain. It's so light. We'll say heavy overcast, if not maybe some drizzle along the coast down to Santa Cruz Tuesday morning, and then clearing out pretty quickly by about 10 or 11 a.m. And then that's it. We'll see another little front pushing into Cape Mendocino on Wednesday, but just sprinkles. And then after that, we think it's a little bit of inland rain, perhaps from that trough on Friday night. This is new. This was not on the models earlier today. So potential for, we'll say, I mean, it's showing some pockets of snow, maybe on the highest peaks, but probably not likely, honestly. It's just too early in the season. There we go. Some more into maybe Tahoe on Saturday night and Sunday, and then clearing out from there. Looking at the temperature forecast, more from a hiking perspective than a skiing perspective. So this is at the intersection of Tioga Pass Road in Yosemite and the Pacific Crest Trail. I think that's up at about, what is that, about 8,700 feet. Temperatures along the line there, 45 to 50 degrees into about Thursday. Then temperatures start falling as that backdoor trough starts pushing down the coast, potentially reaching to the freezing point on Saturday and Sunday, even into Monday. And then things start warming up some after that. So probably not much of a chance for snow, except on the highest peaks. I mean, if you're up at 11,000 feet or above as that trough comes through, yeah, you could definitely get some snow showers. All right, the surf forecast. We'll do Northern California, Half Moon Bay. We see absolutely swell building along the California coast. Tuesday through the day, 11 feet. Yeah, it seems likely. Now, it's probably going to be shadowed in the San Francisco Bay Area, so it won't be that big. But more exposed breaks north and south of there for sure. And then slowly working its way down as we get into Wednesday. And then now this, when you get this sort of broken up pattern, this typically means a bunch of wind and wind swell. And you can see the wind swell fading out as we get into the weekend. Let's look at the pure swell. Here's swell height here. 7.8 feet at 14 seconds. That's solid swell. Again, from a rather northerly direction. This doesn't have it quite right, but you pick it up off the models and you get what you get. Then we get into you can see bits of background swell here, 1.1 to 1.2 feet at 16 seconds with a bunch of wind swell at was it 8.6 feet at 8.9 seconds and 8 feet at 8.7. So just a jumbled mess here as we get into Thursday, Friday, and even into Saturday, slowly fading from there. And then we look down in Southern California, just picked San Diego. You can see not a whole lot happening until somewhere here, Wednesday into Thursday. The swell hit says 2.6, 2.7 feet. I think it'll be a little bit bigger than that. I wouldn't be shocked if it was chest to shoulder high, something like that. And then fading from there. Looking at the swell details, 3 feet at 8 seconds. This doesn't even capture it, but I mean, there's some bits of energy that should slide in there in the 3 to 4 feet at 14-second range. Again, the models have a hard time differentiating between wind swell and ground swell, and when they're both happening at the same time, it just gets kind of confused. Then I picked the North Shore of Oahu. Really nothing going on there. Surfing the 2.5 foot range. Nothing from this low is for, it's well east of the Oahu swell window, so nothing forecast there. Pretty much small to flat on the North Shore and just small background energy for the South Shore. All right, let's go take a look long term. What's going on with our two favorite oscillations, the Madden-Julian Oscillation right here, MJO, and the El Nino Southern Oscillation. These two weather oscillations are the major influencers of the jet stream and weather patterns over the Pacific, especially during winter months, and therefore most likely to influence, hopefully positively, the potential for swell production. So we'll start first with the Madden-Julian Oscillation. It's this periodic weather oscillation. It has two phases, the active phase and the inactive phase. They rotate around the planet from west to east on the equator. The active phase on one side of the planet, the inactive phase on the other, rotating around from west to east. The active phase is like a low pressure system, the inactive phase like a high pressure system. So they're the polar opposites of each other. The good phase is the active phase. It being a low pressure system, when it moves into the far west Pacific, what it does is take warm, moist air at the ocean surface, lifting it high aloft, 30,000 or more feet up into the air. That gets caught by the jet stream. The energy then helps build or strengthen the jet stream, and a stronger jet stream then helps create troughs and helps create storms and improves the likelihood for swell production. Also, the active phase, when it moves into the West Pacific or as it moves across the Pacific, tends to dampen trade winds north and south of where the active phase is. That in turn allows, and so normally you have trade winds blowing. They take warm water from the east side of the Pacific on the equator and it's all bunched up over there on the west side of the equator off of New Guinea and that area. But when the active phase moves into the West Pacific, it starts reducing trade winds or relaxing trade winds, allowing that warm water in the west to start seeping east along the equator, not on the equator, but under the equator. That resulting ball of warm water is called a Kelvin wave. If you have successive active phases of the MJO, they can create successive Kelvin waves. Kelvin wave takes about 4 months. Again, a ball of warm water to travel from the West Pacific to the East Pacific. Eventually, it impacts Ecuador and the Galapagos Islands, and it will then push to the surface, erupt to the surface, and create a warm water slick. If you have successive active phases of the MJO, they create successive Kelvin waves, and then that starts transferring warm water from the West Pacific to the East Pacific, and that is how El Nino gets started. We've had 5 Kelvin waves so far this year, with a 6th in production and starting to move to the east. That is helping to fuel El Nino. Clearly, El Nino is in play. The big drama for the past 2 to 3 months has been, when will the atmosphere become coupled with the ocean? So tonight's video is really about our guesses on, is it occurring? And if so, how strong? And is it going to get stronger? So we're going to dive deep down that rabbit hole because that has been the major issue. And if that issue does get resolved, then that could create major positive drama for the North Pacific for this winter in the form of a legit El Nino. So let's keep going. All right. So this is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. All right. The East Pacific is here. The West Pacific is here. The equator right along here. That is New Guinea there. Okay, where this is wind data. These buoys have wind sensors on them. We only get 5-day average reading. You don't get like the NOAA buoys near shore that we're all used to that give you hourly and half-hourly updates on the wind. But it gives you an idea of what the MJO is doing because the active phase of the MJO reduces trade winds. So we're looking for signs of that. So we're looking at the arrows. The longer the arrow, the stronger the wind. So pretty strong east winds in the East Pacific. All right, no help there. Central Pacific. Again, pretty strong east winds. But as you get to the West Pacific, bingo, west winds, not even anomalies, full-on west winds here. Definite indicator of the active phase of the MJO. Or if it's not, it could be a sign of a building El Nino. Okay, and El Nino effectively is like a long-running, super active phase of the MJO that just, now typical active phase of the MJO runs for about, 4 to 6 weeks, as it takes that long to move from the West Pacific to the East Pacific. But in El Nino, then you end up with an active phase that lasts for 3 or 4 months, if not more. So we're keeping our eyes on this. Now, this is just the average winds. Typically, what you look at is the anomalies, the difference from normal for this time of year. So we have strong east winds here in the East Pacific, but looking at the arrows, They're not really blowing out of the east. Maybe a little one there and maybe a degree or two there, but pretty much this is normal for this time of year. Central Pacific, well, we even have west anomalies, if not neutral, so these are weaker than normal. And I'm sorry, in the Central Pacific and in the West Pacific, full-on westerly anomalies in play. At a minimum, active phase of the MJO in control, if not building El Nino conditions. Put that on your mental tick list as we go through the presentation tonight. We're looking for evidence of the ocean and the atmosphere becoming coupled in an El Nino configuration. This checks off, it appears, one of those boxes. What have zonal wind anomalies been doing the past 5 days? We have that right here, starting September 18th. South America there, Central America there, Hawaii there, New Guinea there, equator right there. The Kelvin wave generation area, the important area where it's in the West Pacific on the equator, from about the 170 west, 5 degrees north and south of the equator, this box right in there. When the active phase moves over this area, that's where you get Kelvin wave generation. We're not so much interested in Kelvin waves per se right now. What we're really interested in signs that the atmosphere is becoming influenced by building more waters off of Ecuador and the signs of El Nino getting coupled with the atmosphere. So on the 18th, the west anomalies are these little orange balls here. Not really a whole lot going on. 19th, same thing. On the 20th, a little bit of a building westerly wind pattern started showing. More on the 21st, more on the 22nd. Okay, so we got, since the 20th, today's the 24th, so we got about maybe 4 days this west wind pattern developing as of right now. Let's keep going. What is the forecast? This is from the GFS model, 850 millibar zonal wind anomalies. These are winds up at about 4,700 feet, but a good proxy for what's going on at the surface. So this is the whole planet. Oranges and reds, westerly anomalies, blues, easterly anomalies. We don't want the blues in the Kelvin wave generation area. In fact, where is the Kelvin wave generation area? Well, this is the whole planet, so there's the date line. Far West Pacific starts about 125 east, so right about there, and goes to about 170 west. So this is what has happened in the past. It's the area right in here that we're interested in. But just looking in the past, September 4th, easterly anomalies. Then we had this building weak westerly wind pattern somewhere around the, the 12th of September or so, and it's been going on for a while. Now, we were supposed to have strong easterly anomalies. And I don't know if you recall back 2 weeks ago when we did the last video, there's a lot of concern about, we're, inactive phase of the MJO. And looking at the actuals, I don't think it really turned out like what the models were suggesting, which is a good thing. Okay, looking forward, here we are at the 24th, westerly anomalies in control. We saw that on some other charts. Easterly anomalies over the East Pacific. They're supposed to nudge into the Kelvin wave generation area for maybe 4 or 5 days here, and then westerly anomalies build. Theoretically, the model 2 weeks out shows easterly anomalies again, but yesterday's model didn't show this, so I think there's a lot of noise out here, and honestly, I'm not so trustful of the GFS model anymore, certainly not more than a couple days out. Let's keep going. Outgoing long wave radiation, OLR. Just another fancy word for cloud covers. If the active phase of the MJO is a low pressure system, most low pressure systems, they take its rising air, warm moist air, lifting up. Eventually it hits cold upper atmosphere, condenses in the clouds, and so this is an attempt to show clouds. The active phase of the MJO would be the blues here. The negative anomalies, basically less sunlight bouncing off the ocean's surface, cloud cover. So, and let's get organized here. South America, Central America, Hawaii, New Guinea, dateline there, equator there, Kelvin wave generation area right there. Now, this is a statistic model. It says basically a neutral pattern holding 5 days, 10 days, 15 days from now. Now, the GEFS model, trust this one a little bit more. This is the ensemble version of the GFS model, suggests neutral pattern right now, but building weak active phase 5 days from now, building pretty solid 10 days from now, and even stronger 15 days from now, 2 weeks out. So I like what I'm seeing here. Let's dig deeper. Next up, the phase diagram for those two models. Statistic model here, dynamic model here, GEFS model. What are these things? Well, the MJO moves from west to east, and this is just an attempt to map out where the active phase has been and where it's going. So it moves from it starts over here, we'll say over Africa, moves over the Indian Ocean to the Maritime Continent, over the West Pacific to the East Pacific, under the United States, across the Atlantic, back to Africa. So the heavy dot right here is where the active phase is. So somewhere, we'll say, somewhere near the Maritime Continent. Now this is the statistic model. 1, 2, 3 different potential tracks, all of it basically. Oh, and if the dots are inside or near the edge of the circle, the MJO is considered very weak. If they're way out here, it's considered strong. So a very weak active MJO noodling around the Maritime Continent, according to the statistic model. Dynamic model has the active phase still weak, but doing a pretty much of a normal thing, going from the Maritime Continent to the West Pacific about a week to 10 days from now, and then over to the East Pacific and maybe even Africa 2 weeks from now. Okay, but no big, strong track. Not surprising, when El Nino's building, effectively the MJO disappears. You say, well, how can it be disappearing? We have westerly winds trying to build over the West Pacific. The thought being that is more symptoms of El Nino, which theoretically maybe is getting coupled with the atmosphere, and not so much a function of the MJO. The MJO, when it develops, if it's strong enough, sort of partners up with El Nino. They call it constructively interfering with it. They're two cycles that both are on the same page, and they amplify each other. Likewise, the inactive phase, when it happens during a El Nino, they destructively integrate with each other, and you get this sort of mixed thing where the MJO sort of dampens El Nino a little bit, but doesn't shut it down. El Nino trumps the MJO when it's in effect, if it's strong enough. Upper level model showing propensity for precipitation. 8 different panels, 5 days of panels, South America, Central America, Hawaii right there, New Guinea there, equator there, dateline there. The greens, areas favorable for precipitation. The oranges and yellows not favorable. Inactive phase, roughly. Active phase, roughly. Active phase in control, making its way across the Kelvin wave generation area into about the first week in October, and then starting to fade. Inactive phase, theoretically setting up mid-October, making its way across the Pacific into early November, and then theoretically the active phase building in behind that. 850 millibars zonal wind anomalies from the CFS model. This goes out a month now. Past performance here, forecast here. The date line runs right up the middle. Again, this is the reds and oranges are westerly anomalies associated with the active phase of the MJO. The solid black contour is in fact the active phase of the MJO. So you can see one here in July into early August traversing the Pacific. The dotted contour, like here, is the inactive phase, the MJO. You can see the blues, the easterly anomalies associated with it. The red, westerly anomalies associated with the active phase. Now, Kelvin wave generation area starts at 125 east, goes to about 170 west. This is past performance here. Here's our forecast. So we have weak westerly anomalies, maybe fading for 3 days, but not giving up the ghost completely, and then starting to build, we'll say a week from now, and then just building and building and building. Active phase of the MJO sets up first week in October, just takes over strong westerly anomalies forecast as we get later into October. That's exactly what we want to see. Another view of that from the CFS model. All right, this is kind of hard to see, but South America's there, Central America's there, New Guinea's there, the equator's there, dateline right there. Reds, westerly anomalies. So this is for this week, westerly anomalies. Notice the building area of westerly anomalies 2 weeks out. This is the 2-week forecast. Then we go out 3 weeks, strong westerly anomalies, totally filling the Kelvin wave generation area on week 3. That's October 8th to October 14th. And then you get the 15th of October through the 21st. Not only do you have strong westerly anomalies in the Kelvin wave generation area, but they completely almost fill the Pacific at that time. That looks really good. And you even have westerly anomalies starting to build in the East Pacific. We've had easterly anomalies over here for weeks and weeks, and that is kind of not really what we want to see. This is the magic sort of pattern that we'd expect during a building El Nino. That is forecast per the CFS model as we get 3 to 4 weeks out, mid-October. Fingers crossed, not guaranteed. CFS model tends to overhype this stuff. But theoretically, if the ocean and the atmosphere are getting coupled, that's exactly what we would expect to see. Let's keep going. And then the CFS model. If you don't believe a month out, then we certainly can't believe 3 months out, but we're going to look anyway because it is fun. All right, this is outgoing long wave radiation. The blues in this case are negative anomalies. That means more cloud cover. That means rising moist air. The oranges and yellow, dry air. All right. Dateline right here. This is past performance down here. This is the forecast. Dateline right there. Kelvin wave generation area starts about 120 east, goes to 170 west. So this is the past area. The forecast is up here. But I'm looking at the past and I'm seeing this pattern of, see the yellows building dry air over the maritime continent with a steadily building pattern of blues over the dateline, more clouds. Then you look at the model, what's forecast, and it's just, boom, a solid area of strong, cloudy air over the dateline. Classic El Nino sort of setup, and bone dry air over Australia and the maritime continent. Drought conditions there. The model says that's where we're headed. Let's now go look at the wind pattern. Pretty much the same thing. There's 850 millibar zonal winds you can see here. This is past performance. The building steadily yellow pattern of westerly winds building over the dateline, while over here you get building easterly anomalies over the maritime continent. Looking at the forecast, and this is pretty much what all the models are saying, you go literally to October 2nd. That is 1 week from now. We have this little bit for maybe 3 days of easterly winds, and not even a week out, the westerly anomaly pattern starts in earnest. And then as we go into October and November, into later November, solid, strong westerly wind burst. I mean, this is classic El Nino with bone dry air over Australia and the maritime continent, and it just continues into December. Let's overlay the MJO, see if we can explore it a little more. Well, no surprise here. Okay, the dotted contour, inactive phase of the MJO. We are 5 days from it being completely over it. I mean, it's basically dying. This has been on the models for 2 months now, that this thing would die. It certainly looks like that's exactly what it's doing. Active phase sets up, constructively interferes with a developing El Nino base state. The two of them get hand in hand, amplify each other, and no surprise you would have a mega westerly wind burst from that. By the time you get into November, inactive phase of the MJO sets up. El Nino base state should be well established by then. Westerly anomalies continuing even with what appears to be a strong inactive phase of the MJO. Now let's overlay the low pass filter. All right, so this is a pervasive high low pressure bias thing. The black contour, low pressure bias. The dotted contour, the high pressure bias. One could say this is the La Nina signal. This is the El Nino signal. So this model, 120 west, is the California coast. Okay, dateline right here. Kelvin wave generation area is from here to about here. You can see nothing but steady building, low pressure over the dateline, exactly what you'd want to see in a developing El Nino system. In fact, today we have 3 contours. Back in June, it was 2, sort of 2.5. We started to 3 contours sometime in July, and that's when things started waking up. We started seeing a lot of signs, but there was still this stall thing that went on from July the whole way up to about a week ago or even today. That appears to be finally mitigating. Change in season is probably helping a lot. But then we go, so we have our 3rd contour. Our 4th contour starts November 11th. Our 5th contour, yes, a 5th contour. I think we talked about this maybe even 2 weeks ago. It's on the charts for around the Christmas time frame. All this strongly suggesting building El Nino, the high pressure bias, the last lingering remnants of La Nina, officially dead as of today. We are in a no high pressure regime, and lo and behold, what do we get? A gale developing off the coast. I'll take it any day of the week. This is looking very good. All right, so what's going on in the ocean? Subsurface. We have data from the TA buoy array. Again, that series of buoys strung across the equator used for monitoring El Nino. Well, let's do what they are meant to do. Let's look at the thermocline. West Pacific here, East Pacific here. This is temperature, subsurface temperatures down 100, 200 meters. Really, it's the top 150 meters of the ocean surface that you're looking at. Kelvin waves traverse west to east on about the reaching down to about 150 meters. The 30-degree centigrade isotherm line right here at about 158. I think that's where it was 2 weeks ago. The 29-degree isotherm, pretty much unchanged. The 28-degree isotherm, pretty much unchanged. The 24-degree isotherm, it was down at, what was this, 25, 50, almost 60 meters deep at one point. A little bit shallower there at about 27 meters, about where it was 2 weeks ago. So no big change. But that's the average. Let's look at the anomalies. Difference from normal for this time of year. Clearly, no cold water in control. This is all positive, warmer than normal water. We see, well, the first thing that catches your eye is a massive ball of warm water, 3, 4, 5 degrees above normal. I'm tracking pretty much every other day the edges of these lines, and they're not moving much, which means there's a persistent pool of cold water lingering here, waiting to erupt to the surface. Then you have these 2-degree anomalies here. That is a Kelvin wave developing associated with a westerly wind burst that happened with the last active phase, the MJO, backfilling in, feeding this pool, all of it erupting to the surface, then getting caught by trades and dragged off to the west on the ocean surface. All this is clearly suggesting an El Nino pattern developing, not as strong as it was, but because this water is erupting to the surface, but still there is 3 or 4 months worth of warm water here. Let's say 4 months. So we are, let's say October, November, December, and January at least. We have at least that long before we run out of warm water to fuel El Nino. And typically El Nino peaks in like the November, maybe December time frame. Plenty of warm water in play to support that sort of a scenario. There's another version of this data here. I'm not really looking at it. It's old. It's from the 5th of September. It hasn't been updating on NOAA's site. And likewise, the sea level anomalies, they haven't updated since September 5th either, so we're just going to blast on by that. Upper ocean heat anomalies, though, we can look at that. It's updated as of September 20th. You can see this again, West Pacific here, East Pacific here. We're going back a year, October 2022. Cold water in the East Pacific, La Nina in control, and somewhere and warm water all balled up in the West Pacific. Somewhere around November, active phase, week 1 setup, created some westerly anomalies. You see this little finger of warm water intruded in and sort of cut the legs off of La Nina. Then another Kelvin wave from the active phase of the MJO in January. That was number 2. Kelvin wave number 3 here in March. Number 4 in April. Number 5 in May. Then we had a little bit of pause in June and July. We had another active phase in the late July, August timeframe, and it has created yet more warm water pushing off to the east. Now you see a little bit of neutral water starting to build here over in the West Pacific. Not unsurprised. In fact, during super El Ninos, this actually starts happening in the July time frame. So we're a little bit late in the schedule here. Temperatures not quite as warm as they were at one point, but it was so cooking hot in June and July. I mean, it was like scary, strong super El Nino looked to be building. Now this is looking solid, but not as scary. Upper ocean heat anomalies for the area from the date line over to 100 west, so that's almost to Ecuador. You can see back in October, nothing but cold water in the East Pacific. And then, boom, here was your big spikes of warm water, another spike. We're down in the lower side of that still, but piles of warm water still in control, subsurface in the East Pacific. All right, let's go to the ocean surface. See surface temperature anomalies. All right, so Chile here, Peru, Ecuador, Central America, Hawaii out here. Clearly you can see warm water all piled up off of the Galapagos are there, all in this area. Now, not as warm as it was. You know, I'm still thinking there's an easterly wind thing going on here that's tamping down the extent of the heat in this area. That said, if westerly anomalies start building across the Pacific like what we saw in the models, you should see this steadily building. That doesn't mean that there's some new Kelvin wave erupting. It's just showing the existing heat that's already there that's sort of masked by the easterly wind event. Now, you can also see solid warm temperatures out to, well, that's 140, 150, maybe 155. So this is your clear El Nino signal. Lots of warm water, Kelvin waves erupting along Ecuador, getting caught by easterly trades, dragged out into the official El Nino monitoring region. They call it the Nino 3.4 region. Goes from 120 west, 5 degrees north and south of the equator, out to about 170 west. So clear signs of El Nino in this image. The 7-day trend, again, Chile, Peru, Central America, Hawaii, equator right there, dateline right there. We see warming temperatures actually along the coast of Peru and Ecuador and out along the equator. I think this is more attributable to perhaps easterly trades there diminishing somewhat, and so the water temperatures warm up because there's less upwelling and mixing on the surface. More than, this is not really an instance of, oh, all of a sudden there's like a new Kelvin wave erupting. It's been a steadily erupting fountain of warm water for months now. This is a function of trade winds, I think. The backed off view here, again, showing the clear this is the classic El Nino signal, warmer than normal temperatures off of Central and Central America and Ecuador the whole way out to the equator and beyond, almost reaching over to New Guinea. Plenty of warm water to work with. Sea surface temperature trend. Now this just shows you in the Nino 1.2 region, this is the area right there along Ecuador and the Galapagos Island. These temperatures in reality are about 0.2 of a degree below normal, below what NOAA considers the official values. But you can see today we're at plus 2.3 degrees above normal. That's centigrade. That's much warmer than normal. Here's neutral. Clearly piles of warm water, and it really hadn't changed much at all since July, August, September. Just steady warm state. Maybe not as warm as it was at some of the peaks here, but still quite warm indeed. But the official El Nino monitoring region, the Nino 3.4 area, again, we talked about that earlier. You can see a steady, slow upward trend. Today's value plus 1.231. All right, we were a little bit higher at times back in late August and we'll say early September sort of thing. But this is about 0.2 of a degree below normal. But regardless, neutral is right here. If you're half a degree above normal for 5 consecutive 3-month periods, you're considered in weak El Nino status. If you're 1 degree above normal, you're at moderate El Nino. If you're 1.5 degrees above, you're at strong status. So this is looking like we're right in the area of moving into strong status. In fact, let's dig in just a little deeper. These are the official OISST values for Nino 1, Nino 2, Nino 3.4, and Nino 4. The 3.4 region's the official El Nino monitoring region. These are weekly values. You can see back around April, we were dead neutral. This is the one that matters, this column right here. You see the values. These are the actual average temperatures. This is the difference from normal for this time of year. Half a degree above normal started in May 10th. We went to 1 degree above normal in June 21st. And now 1.5 degrees above normal. This puts us in moderate status in August 23rd. Going up, the past 3 weeks have been, well, these are actually, this is a week old, but 1.6, 1.6, and 1.6. We're waiting for the next update to come to see where it's at. But so this all says moderate El Nino, strong El Nino at 1.5. If we get to 2, that's the real question. Then you're in super El Nino status. Don't think we're going to get there, but you can see the steady upward trend is occurring. All right, so here's a picture of sea surface temperature anomalies for this year. Look at the pattern. We'll do a quick comparison here to 2015. Wow, looks very similar. In fact, let's do a quick dive here. So warm temperatures here, the reddest go out to about 135, but you see steady warmth out to past the date line. During 2015, you see maybe a little bit preponderance of deeper reds out to 160 instead of, 135, is that what I said? 150, sorry. So a little bit stronger here. Temperatures look the same, but it all chops off right at before you get to the date line, where this year's event goes way beyond that. So as of right now, the 2015 El Nino, which was a super El Nino, looking, I'd say, pretty close to what we have today. Now, the gold standard is the 97 El Nino. There is no comparison. Very cooking warm this time of year, 23rd, 1997, in the Nino 1.2 region. Notice it doesn't extend that far out, though. It's just limited right to here, where this event, and I'm thinking I think these temperatures are actually warmer than this in this year's event. I think there's still a wind thing going on. We'll know more in the coming weeks, but right now, I'm not going to argue it. We'll just say 97 blows both these other events away. It was a super El Nino. 2015 turned into a super El Nino. Right now, 2023 looks very similar to 2015. We'll see how this all plays out. Next up, sea surface current. This is New Guinea here, the equator right here. Dateline is somewhere. Let's see if we can find it right there. Oops, I'm off by 10. Dateline is, it's more over here. There we go. Right there. All right. Westerly current, driven, we think, by the Walker circulation, driven by westerly anomalies, warm water sweeping off to the east. And then we go over to the other side of the Pacific here. There we go. And Ecuador there, Galapagos there. You see this easterly current thing. We think that's those easterly winds that we were talking about. Maybe driven by the Walker circulation, maybe not. Hard to say, but we think that's dampening perhaps sea surface temperatures a little bit here. And we're looking for the intersection of, well, there's your east and where's your west? Your west is about here. Maybe the dividing line somewhere right around in there, roughly, and that is at 174 west. That's about where it was 2 weeks ago. So, and that's where the center of low pressure is supposed to be, the low pressure bias. So that would all sort of make sense. Center of the Walker circulation, probably somewhere right around here. So another piece to the puzzle. What does the atmosphere think is going on? We're going to look at the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Central Pacific and Darwin over in the Maritime Continent. When pressure is lower in Tahiti as compared to Darwin, the index goes negative. When pressure is higher in Tahiti than Darwin, the index goes positive. We want to see negative because that means lower pressure in the Pacific. That means at least the active phase of the MJO, if not a building El Nino. Today, we're at minus 7.6, but we were at minus 26 for days. Scrolling down here, negative, 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 negative. We've been negative for 35 or 40 days now, and then we were positive for 7 days, and then we were negative for another 25 days before that. The 30-day average falling, minus 15 actually rising just a little bit, 15.63, but a month ago we were at minus 8.4. We're going in the right direction. During El Nino, at the peak of El Nino, this will go down to 25, but we're starting to move into the right area. The 90-day average, minus 8.8. Where were we a month ago? Minus 5.2. So it's slowly moving, but again, this is 90 days back worth of data. We expect this guy, because this guy has been negative for basically 2 months or more now, we expect this guy to start falling off the chart any minute now and going real negative. And then that also would be an indicator. The atmosphere in general is looking like it's starting to trend towards El Nino. Here's the 30-day moving SOI all graphed out. Again, neutral is right in the zero. Up here in the positive range, La Nina territory. The upward spikes are the inactive phase of the MJO. The downward spikes, the active phase. You can see clearly back in January 2021 when we were in La Nina territory, everything was positive. Continued until we got to January of this year. Active phase, active phase, active phase, just pushed us deep into into negative territory. And then we got this stall in El Nino development that started pretty much late June, went all the way through July. A little bit of a push in August, but then we just bottomed out. Now we're starting to move our way down again, all suggesting a potentially developing solid El Nino. I forgot to show this before. This is outgoing long-wave radiation anomalies, actuals, not modeled stuff, and a different depiction of it. Dateline running right up the middle. Clearly you can see the oranges, reds, yellows here. Positive outgoing long-wave numbers suggesting cloud-free skies, where all your cloudy skies, blue was over the Maritime Continent. Now here we are. Look at this. The building, clouds, building more. Not as solid as this was, but starting to suggest a building cloud pattern over the dateline, while you have this building dry air pattern, again setting up over the Maritime Continent. We expect the contrast and the strength of both of these to build as we get into the coming months. All right, and finally, sea surface temperature anomaly projections for the Nino 3.4 region from the CFS version 2 model, the official El Nino monitoring region. Again, 0.5 degree is minimal El Nino. 1 degree is the starting point for moderate. 1.5 degrees for strong El Nino. We've already, according to this is the uncorrected data for the CFS model in September, pushed into strong territory. Now the model says in October we're going to backtrack. I don't really see it. I don't know why it's saying that, but it is saying it. And then it says as we get into November and December, we rebound with temperatures moving to 1.7 degrees or 1.65. So it's pretty solidly into strong El Nino territory, and then slowly traveling downward, probably approaching neutral back in coming July. Then there's the PDF corrected version of that same model suggesting temperatures dropping down to 1.1 degrees in mid-October and then rebounding to about 1.4 degrees. So you have a range of 1.4 to, we'll say, 1.7. The midpoint there would be 1.55 or something like that, 1.6. So weak a weak, strong El Nino. I think that's probably too conservative, and I'll show you why. Here's the consensus model released this week of all the El Nino models. So here's all the dynamic models here, and you can just, and here's all the statistic model. The CFS model, let's see if we can see this. It's, whoops, that line right there, 1.73 degrees. But you see there's a whole bunch of models way higher than that. And then the statistic models all tend to be low. Let's drill. I mean, just eyeballing this, you can see the dynamic models right there. The average is 2 degrees, 2.07 degrees above normal in probably December. That's super El Nino status. The statistic models say 1.37, so that's just moderate El Nino. The CPC, oh, that's the average for the statistical models. And let's see. The CPC consolidated, that's what I was looking for, 1.37 degrees. I think that's a little bit on the low side. So here is sea surface temperature anomalies again, but here's each of the individual models. These are the dynamic models. The peak right in here, the average for all of them, 2.073. You can eyeball this. The CFS model is right there, 1.83. And just going down here, there's only three models that are lower than the CFS model. All the rest of them are higher in the two. One of these says 2.83. That's ridiculous. 2.2. The ECMWF model, well respected. That's the other global model, says 2.24. Okay. The statistic model's all way on the low side in the 1.1 to 1.6, or there's 1.8 there. I'm tending to track more in this range in the 1.8, 1.7 degrees above normal range, maybe even a little bit higher. Let me know what you think. 2.073 is the average for the dynamic models, 1.392 for the statistic. All models say 1.838. That would be a good target. That's strong El Nino. Not super, but strong El Nino. And that's what we've been talking about on the forums a bit. Somewhere temperatures, everyone's throwing their dime in the hat here. And I think on average, we're saying somewhere between 1.6 and 1.8. So we're getting closer. We'll see if we hit the money. All right, so quick summary here. New developments. Cloud cover building, negative OLR, near the dateline. Has been since June 24th. Evidence of the upflow into the Walker circulation there. It's getting better defined. Not super defined, but way better than we were 2 weeks ago during the last video. Equatorial current suggests the Walker circulation stronger at the surface. Yeah, it is. Not what I want to see, but it's there. The North Pacific jet stream is improving for sure, but likely that's more just seasonal. We're moving into the fall season, so it's normal that it would be getting stronger. Now, key piece of evidence. The SOI is building in duration and intensity, and it's building in the negative way, suggesting development of El Nino. West wind anomalies holding over the Kelvin wave generation area since July 15th and are forecast to build strongly according to the CFS model and everything but the GFS model, and starting about 5 days from now. So we're getting close. New Kelvin wave development continues. Yep, Kelvin wave number 6 continues out there somewhere on the dateline. And so models all suggest more of the same moving forward. The CFS version 2 is even on the weak side. Many other models suggesting stronger than what the CFS does. And then, of course, we've got this mega active MJO forecast in the all of October into at least mid-November. That should be a mega influencer on the development of El Nino. Unknowns. Is the Walker circulation building towards El Nino? Yeah, I think it is, pretty much. I mean, we upped the confidence here, 90% now. Will west wind anomaly pattern continuing over the Kelvin wave generation here? Push that up too to 90%. Are more Kelvin waves in flight or expected? One more. That's nothing new. Is the ocean and atmosphere coupled? We're getting there. We're saying 75%. That might be. Maybe we're at 65 to 70%, but we'll go with it. Will the warm pool in the east discharge before coupling occurs? Not even a chance. Is model guidance believable? I'd say the consensus model is pretty believable. It says temperatures 1.75 or something like that, so we'll give it 80%. So the really good news is we have potential for surf. We have a developing gale, finally, the end of September, off the coast of Oregon. Likely going to generate some swell, probably be pretty raw since it's so close to the coast. But then the model suggests yet another system behind that, and potentially another behind that. Jetstream looking good, potential for swell development looking great. We got surf on the way. Hooray! Looking longer term, El Nino looks like it's getting good traction. The SOI is dropping. We went through all the data. It looks like we're off to the races. We're coupled. Not as strong as we'd like to be, but we're getting there, and we think that's only going to build as we get into October with the coming active phase of the MJO. El Nino status, probably reaching well into strong status, but later than expected, probably not until the December timeframe, which is okay. That's fine. The longer the better. The more influence on the atmosphere, the better. We had hoped that we would be off to the races in September or even late August. We're nowhere close to that. We're not in the scenario of the 1997 El Nino, but we're building, and we think we're getting traction, and it's only going to get better from here. So that is very encouraging. Finally, some good news. The paint is drying, and it's drying in a pattern and a color that we like. All right, that's it for this week. If you enjoyed the video, give us a thumbs up. If you have questions or concerns, write your comments up. We'll be happy to answer. We try to do it pretty quickly. If you'd like to make a special donation, use the super thanks button, the heart with a $sign in it down below. And other than that, we will do this again next week. Same time, same channel. No more vacations planned. The only thing that might interfere with our videos moving forward is that we'll be surfing. That's our hope. All right, see you next week. And enjoy, stay safe.